the pad, and it should be everybody in the world. Morning crew, and welcome back to the Andy Mechanic YouTube channel. Now, as you all know, I've been really busy in the oil workshop, putting up shelving, racking, beams, lights, you name it, during this lockdown period. And as part of that process, in the actual fact, it was to do some of the conduits on the distribution box that I did for the wiring a few weeks ago. I had to use my trusty old Bosch mains powered, yeah look, mains powered 240 volt AC, mains powered electric drill, sort of traditional style drill, yeah, pistol grip, off you go, none of these silly batteries to keep changing all the time. And I've had this for a very, very long time. I was trying to think last night just how long I've had it. I know it came from England. I didn't buy it here, I'm sure of that. And I've been in New Zealand for 11.5 years, and it's probably getting close to 20 years old. It's a Bosch PSB 600 RES, which means it's got reverse, I think it means it's got reverse anyway. It's an impact drill, so it does the old masonry setting as well as normal steel and stuff, normal drilly stuff. And a while ago, I got asked to put up some security bollards and some steel work at a motorcycle shop that I used to do a bit of work for. And the wall, I'm not kidding, the wall that I had to drill through for the bolts was like over a foot thick. And I think at that point it was way beyond a little tiny drill like this, because we were there drilling for hours trying to get the holes drilled through. And it got very, very hot, and since then it's been a bit weird. And when I was putting in, just doing like an 8mm or a 10mm masonry drill into the concrete down there, only a few holes to do, it was getting late in the day, it was quite dark, and I noticed when I was using the drill, it seemed a bit underpowered, and there was some massive arcing going on down here. This is obviously a vent. I think the brushes will be somewhere in this region here, and it was really lighting up. Now that sort of made me stop, because it didn't look particularly safe to me. And I remember years and years ago, it was a Black & Decker drill, and it was actually it was a metal cased drill, very, very old, that I was using. It used to belong to my dad's. It was like a light browny kind of casing colour, very traditional Black & Decker, again mains powered, and that was doing the same thing, but I didn't know what it meant, so I just kept using it. And then all of a sudden there was a huge bang and lots of smoke, and it absolutely scared me shitless. Like I say, I was only a kid, didn't know what was going on, and of course Dad wasn't over chuffed either. So I have come up with a plan of basically testing this to destruction, because it's too far gone. They're not worth fixing, these drills. When they wear out, you just throw them away because they're quite disposable, and you go and buy a nice new one. And I'll be looking forward to doing that. But what I wanted to demonstrate in this video is what can cause that arcing. So we're going to strip it down, have a little look inside, nothing too detailed, a quick sneaky peek inside the drill casing, see what's going on. We may well find that the brushes are worn out. That's the most likely scenario. And then we're going to stick it on the lathe. I've made a little jig, and we're going to stick it on the lathe, and it's going to power the lathe. The lathe won't be connected to the mains. What I need to do is to put this drill under load, so that the action of turning the chuck on the lathe, there's quite a lot of drag on that, will provide quite a bit of load for this drill. We'll run it on full tilt, and we'll see how long it lasts, and it'll go boom, hopefully. I don't know, it might do, it might not, it might just stop. And then once it's cooled down and all the dust is cleared, all the smoke is cleared, then we'll have another little look inside and see what damage occurred. And the warning is to people out there, to the viewers and friends and whoever else talks about this, is if your mains powered drill or sander or whatever it is starting to arc, and you can see a lot of light and flashes coming from the brushes area, that's time to stop using it. Don't continue, or catastrophe may well happen. My main concern was I might have got a shock from it, and I didn't want that. That wouldn't have been good because we're in lockdown. I couldn't go anywhere. Going to hospital would be a bad idea, wouldn't it? I don't want to catch the bug. So, without further ado, because I do ramble on, let's get the camera set up and dig into this drill. Here we go. Oakley dokley. Right, well, I've never been inside this drill before. So it's a T20. Oh my word, that was loose. Huh. I've never had to repair it. It's never broken down. It's just slowly demised as this thing. It's actually been a really good little drill, and it wasn't actually all that expensive when I got it. And that was loose as well. Jeez. As you can see, it's been well looked after. This thing has been massively abused. Okay. It's a testament to Bosch, actually. Made a good bit of kit. Well, we went into level 2 yesterday here in New Zealand with this whole plague thing that's going on. So hopefully things are going to get back to normal soon. Been waiting to do this video for quite a while, actually. It was about a week ago, I think I used or maybe even 2 weeks ago, I actually used is not all of them used the drill. Okay, well, it looks like obviously it splits down the middle, but we've got this rubberized piece on the end, so that should hopefully just unclip. I'm not too concerned if I break it, in all honesty, because if all goes to plan, this thing's gonna... Did I break it? I did break it. That's all right. It's okay. Had a little clip down there. Don't really need that anymore. Okay. Now let's see if we can split this casing open. I want to have a little look to see what the condition of the brushes is right now, and then we can get it put in the lathe and get it fired up and see if it's going to explode into a million pieces, which it probably won't do. Did I undo that one? I didn't. What a numpty. Ah, because these were hidden, weren't they? That's right, these are the extra ones. What a donkey. Are we still on camera? We're not really on camera. Frame the shot, Mr. Young. Okay, I think that's all of them. These are loose. Yep. Okay, let's give it another go. Definitely feels like it wants to come apart, which is good. Oh, hang on, there's something going on with the top here as well. This plastic piece bridges those two, doesn't it? So that's going to have to come out somehow. Ha! There we go. Excellent. And that there's for holding the chuck, because it doesn't have a key on the chuck. And that was really good, actually. I like that idea. We've got a sticker, so we need to... Hopefully I've not got the virus. Right, well, just going to cut that sticker down. Do not press until chuck stops rotating. Yes. There we go. Now we should be in business. Now, I'm not sure which side all the gubbins stay in, but we'll soon find out, won't we? Now, this is the time to be a bit more delicate. Trying to keep the whole thing in shot for you. Oh, there we go. Fantastic. Right. Jeez, look at all this. Nice. Reduction gearbox, that's cool. The windings look pretty good. That's the brushes I want to take a look at. Okay, so we've got the trigger mechanism. So if we can get rid of that, that'll get rid of the cord as well. So I'll get some little long nose pliers and First of all, we need to mark. I'll just put a blue marker on there for the blue cable. Right. That's that one. Get out of the clip. Should have taken it out of the clip first, donkey. Right. This is the direction changer. We can see the brushes in the end there, look. They should be, I reckon they'll be pretty worn because it's done a hell of a lot of work as this thing. Alright, what else needs to come out? I want to take the motor out and have a look, have a proper look. I think it's going to come out with the gearbox and everything. Aha! Right, I'll try and keep all that together if I can. For now. Get rid of that one. Forwards and backwards switch. Very nice. Okay, now we should hopefully be able to just pull that out of the drive and keep all of that lot in one piece. I don't fancy putting that lot back together. Okay, roll the motor over, pull the wire out of the clip, and let's just get that one taken off. There we go. Right, now we can get rid of the flex and the switch. That's out of the way. Okay, Mr. Motor. Let's get some light on the matter. Okay, so a bit of a close-up on the winding. This looks a bit overheated. It's going a dark sort of cherry red compared to some of the other windings. Like around here looks a much better condition. So it's definitely got hot. I know it's got hot actually because I got it really hot one day. Okay, and these are the brushes, as James would say, Mr. May. Okay. Don't look very serviceable. I'm just going to put a mark. In fact, let's just put a mark across there so we can't get it the wrong way round when we come to reassemble. Now I don't want to damage this because otherwise it's going to destroy our experiment, but I do want to have a little look inside, see how much brush is actually left. I wonder if I can just bend those little tabs, pull the spring out and extract the brush that way, and then we can just bend the tabs back later on, can't we? Let's do that. Oh, how's the new camera, by the way? This is my S20 Ultra that I'm filming on today. So hopefully you'll be getting a better picture. I don't know. Right, that spring should come out now. There we go. And there is the brush. It's got a little bit of damage. Hopefully it's going to focus for you. We've got a chunk missing off the side of the brush here, which potentially is going to reduce the number of windings that are energized because it may not be bridging as many of the commutator segments as it would normally do on a full width brush. Is that going to come out of there? It doesn't want to come out. Oh, why? Okay, let's get the other brush out. And there's the other part that snapped off. That wasn't me, that was already broken off. Okay, let's just mark the brushes. I want to put them the same in the same holes. This is cool. I like taking things apart. Putting it back together again might be a bit more of a problem. I'll have to watch the video, won't I? Right. There we go. Mr. Brush. Out he comes. Ah, now that one's in much better condition. Look at that. That's what a brush should look like. And it looks like there's still plenty of meat on them. So why it's arcing, I don't know. Unless it's because of that broken brush. I don't know. Strange. But I would like to get the armature out. If possible. Is it going to come out? I don't think it can come out. That's bizarre. I think it has to go out that way
So you take the brush pack off, which I don't know how it comes off. But it's got the big wheel on the end, which is sort of bonded in place. So we're not going to be able to get the armature out, unfortunately. That's just the way it is. So all in all, it doesn't look too bad. It really doesn't. You could test the commutator. If I could get it pulled apart, I could do a continuity test on those. The actual commutator itself, that does look quite black. So that's going to obviously reduce, it's going to be a point of resistance. Oh, bearing's good. But as regards why it was arcing so badly, I don't really know. It doesn't seem horrendous. That should come out of there. It really should come out of there. Ah, okay. So we got the fan taken off. In which case, if we can get this brush pack off the end, then we can extract, can't we? Okay, it looks pretty fixed up here. That's how they've glued it on. Now, there is a little tiny screw that I've just noticed there. And one there. God, they are tiny. Let me get a different screwdriver. Hang on. Okay, we better mark this as well, just so we line that up. It's all about marking stuff, isn't it? It's so easy to get things put together wrong. So we can't really get in there to undo that screw, so it must unclick off here somehow. Oh, you're joking. Look at that. That's brilliant little design, is that? I like that. So you just line those, where was it? There's your contacts for your brushes. They run on these little strips. That's good. So I think it goes in there like that. In fact, let's take the old... we still can't get the armature out yet. That's bizarre. Very clever. Okay, maybe it went in there. There we are, look. Right, so then it turns around and lines up with the mark. That's brilliant. So we know how that goes together now. Just keep turning it anti-clockwise, and it's actually sort of spring-loaded as well, which is cool. Okay, now we can get to those little screws. Hopefully, there's obviously got to be a contact between this and... Oh, it goes in there, look. I love taking things apart. I think it's so cool. Right. Obviously, I don't want to break any of the circuitry. So anyway, let me know what you think about this new camera. If it's better quality than on my other videos. Not just the visual, but the audio as well. Because it's nice to have a bit of feedback. Poor drill. I don't know. Okay, I'm not going to take that off. I have a sneaky suspicion that it might get, it might be a point of no return. So screw those back in again, and we can test the. Oh man, that's the wrong size screwdriver. We can test the commutator segments and the windings. I'll go and find my multimeter. I've got a pretty good idea. I know where it is. Right, that one's in. Why can't we get this one in? There we are. Just required a bit more grip, a bit more effort. There we go. Right, I can't find my multimeter. Right, can you see that? You can. Well, you can hear it anyway. You don't need to see the meter really, do you? Okay, here we go. Right, double check. Yeah. Right, that's one. Well, obviously it's, what's it called? Lap wound, I think. I'm not a motor expert, so I could be wrong. But you can see when I'm touching the clean commutator there, where the brushes don't run, it's a very clear contact. But where it's all grubby, it was a little bit more. There you are, look, you see I'm actually touching it, but it wasn't making contact. So that's probably the cause of the sparking, to be honest. It's poor contact making it spark. The brushes hadn't fully worn out, so. Right, let's keep going. Twist it round a bit. We've not found any problems yet. Other than the condition of the commutator, obviously. We're testing the windings at the moment. So you can see, look, if I move it up and down, very poor contact, isn't it? Okay, well, electrically, it's sound. It does still work, don't forget.
Right, it's time to do an impersonation of James May now and get this thing reassembled.
Showing off, don't wanna have to wait tonight. Better off, I'm gonna find my way tonight. I wanna heal your sorrows. We'll make a new tomorrow. One night to find the answer. What makes this heart beat faster?
Now the question is, will it still work? I don't know. Have we already broken it? I need to cut these cable ties. Hang on a minute. So we've got to plug it into the mains, risk life and limb, and see if it's going to be all right. Because, well, we need to know it's going to work to test it. And not test it, but test it to destruction. Okay, it's turned on, it's plugged in. Are you ready? That was a bit harsh. Look at that. That's a lot of arcing going on in there. Ooh, you can see it shining up my face, lighting my face up. Oh man, I think we'll get a really good close-up of that. Bloody hell. Got to look down through the hole. Ready? Holy moly! Wow, that doesn't look good. That really doesn't look good, Gromit. This is going to be great. Okay, right, let's get it mounted up in the lathe and blow it up.
Oakley dokley. Right, so that is gonna. I made all this yesterday in preparation for this big adventure we're going to go on. So that's going to go in there like that. Oh, sorry, camera. And now we need to tighten up the chuck. We've got this little drive shaft, which is going to drive, basically provide drive to the lathe. There we go. Look. Right. That's good and tight. So we've got the electric drill via this sort of drive shaft, prop shaft. I've aligned everything properly, so it should be pretty good. That's going to rotate and drive the lathe. Now the lathe is not going to be plugged in. The lathe is just providing a load on the drill, because there's no point running it up unloaded, because if we did that, it could take a very long time to fail. No, we need to put a hell of a load on this drill, like it was when I was doing the masonry drilling, and get it hot, and then we should see a failure. Right, we're going to get the rest of the cameras set up, because we need at least, at least 2 or 3 cameras to film this with, and I might even get the old Pico out, and we can measure the current flow to the drill, and we'll see how that changes as the drill fails. Woohoo! It's looking pretty good. We're all set up. The drill is mounted to the bed of the lathe. We've got the rod connecting it to the chuck. It does work. Woohoo! We've got GoPro cam. We've got S20 cam. We've got S6 cam that's going to go in that tripod. And of course, we've got the Pico setup. And we're using... Now, bared back some of the, well, not bared back, taken the main insulation off, and we've got the amp clamp set on the lower setting, which is 20 amp setting is 100 millivolts per amp. So every volt on the screen is 1 amp. Sorry, it's 10 amps. So every volt on the screen is 10 amps of current at 240 volts AC. So we're using a maximum scale of 5 volts. We're on AC. I don't think that makes much difference, actually, to be fair, on this one. And I've got 20 seconds per division. Sorry, yeah, 20 seconds per division. So we've got quite a long capture time, because I don't know how long this drill is going to last. Could go on for ages. Don't know. Right, now is the time. It's now or never, isn't it? To find out if this drill, or what's going to happen to this drill when we overload it and essentially run it to death. Cross your fingers we don't blow up the workshop. Here we go. Oh, it could all go tragically wrong. Right, quick. Okay, it's cool. We're good to go. Just reset that again. Okay, we're ready. Let's just get the old zip tie around there to hold the throttle on. Jeez, this is going to disaster. Holy shit! Interesting stuff. Wow! Sorry, Bosch. My bad. Better unplug it. Ugh. Right, we'll stop the capture. Ha! You can see the laptop. Jeez. Well, that happened a lot quicker than I thought it was going to do. The workshop is now full of smoke. I think it looked pretty cool, actually. Came out pretty well, and as predicted. Oh, you're really close. Go over there, look, that's better. It's very acrid in here. So the power's turned off. I've still yet to save the Pico file. We'll take a look at that in a minute. There's a fly about to die, obviously committing suicide because of all the smoke and everything. Yeah, so we had the GoPro running, we had the S20 phone running, recording, and the S6 Edge. So we had 3 different angles to capture that excellent pop at the end, which was pretty cool. Okay, I'm going to have another slurp of my coffee. I'm going to wait for the whole thing to cool down because that drill got pretty hot, and that's exactly, the smell I was getting was the same smell I was getting when I was using the drill, and it also brings back memories as to when I was drilling that really thick concrete wall a few years ago to put the bolts in. So we'll let it all cool down. We're going to pull the drill apart and see what failed. We saw a hell of a lot of smoke coming out of it. And then we'll also take a look at the Pico file, the current draw of that motor, and see how that changed as the drill was starting to demise and what happened right at the end. I have no idea. I didn't even look. Okay, right. I'm going to have another coffee and let this smoke clear. Oh, it's still smoking. Right. While that's cooling down, let's take a quick look at that Pico file. Right, this looks really interesting, and initially you can see, just let me zoom in a little bit. We can see here, look, that's the whole event, less than 3 minutes. That's incredible. So we've got the initial start here, look, of the motor starting to turn the lathe round, and of course it's going to draw quite high current to get the lathe moving initially, and the current there, just going on to that one, is 1.7 volts. So that's 17 amps of current momentarily. That's quite a lot for a little electric drill, to be honest. And then it sort of levels out, and it's doing okay. You know, the first couple of minutes it's doing just all right. And let's just zoom in a bit, because I know we've got lots and lots of detail here on the old Pico. There we go. So we can see there, look, the alternating current, and it was pulling about 8.7. Yeah, because 1 volt is 10 amps, so about 8.7 amps of current, you know, once it got the lathe up to speed. And this went on for quite some time. In fact, we can even measure that. So let's get the other end in before it starts to increase current again. There we go, look. Okay, so as regards time, if we measure between these 2 points here, so about there, it sort of settled down. And then if we go on to that point there, look, there's a distinctive rise, and we'll look at that in more detail shortly. We had a period of 1 minute and 43 seconds where the drill was still operating normally. So from when I gave up using the drill to drill the holes in the concrete the other day, it was already very close to completely failing. It only had 1 minute and 43 seconds life left in that drill. It's pretty cool. Okay, let's focus now a bit more on the end occurrence, because that's really the critical point, isn't it? Now, I did go and check in the house to make sure it hadn't popped the circuit breaker, which it hadn't done. So that's the waveform there. Look, that's the current draw, and it's slowly increasing. It's very cool, isn't it? What you can do with a scope. Very impressed. And we got to a maximum current draw of, so a little measure of that one again. Ooh, where are we now? So basically 2 volts, so 20 amps of current was flowing right before the drill popped and failed, and we saw all the smoke and the flash come out. So that was pretty impressive stuff. But if we just go back and look at the period of time it took to completely demise, go on Pico, wake up. Let's just get rid of that and start again, because sometimes it gets a bit, there we go, look, that's what we want. So I just want to measure the period of time from that step until the end. So if I just close that, there we go, and we'll just measure again. So we're going to go from where we saw that sudden hike in current flow, that step was really the start of the demise, to the end was only 19, well, let's say 20 seconds, or 19.82 seconds. So from when it started to fail to when it completely stopped and it let all the smoke out, 20 seconds. Pretty bloody cool, actually. Right, let's go and see if it's cooled down. Jeez, it still stinks in this workshop. Right, we can get rid of that now. Never again. Hopefully dokely. Well, let's just loosen off that. Jeez, it's still hot. Oh my god. Right, that's the chuck loosened off. Now just the pinch bolt. All this for 3 minutes of last life of the drill. It's a pretty good flash though, wasn't it? I was quite impressed, to be honest. I was pleased I wasn't anywhere near it. Right, that should be enough. Oh, I think the drill is just cool enough. You can still feel quite a bit of heat in it. I should have put a temperature sensor on the side of the drill as well to see how actually hot it got. Next time, hey. So let's get this thing pulled apart and see what failed. Remember, there was a lot of smoke coming out of the fan area here, but the final pop was out from where the brushes were, where we saw those sparks earlier on when I ran it on the bench. Poor little drill. It'll go down in history now, won't it, as being an abused little drill. Okay, let's work our way in and see what really happened. Right, well, first job, we can get rid of the plug. Save that for another day. And I can get rid of the cable, because that's really annoying. And I can reuse that on something else. Perfect. Right, next job. Oh, it's still hot to hold. We get rid of that tape that we used to sort of fix my breakage. And we'll get rid of that. Right, we're going in. Bear with me. You've got to place your bets now as to what you think failed, or what components failed. Was it more than one failure? Because it stopped dead, didn't it? And we had a 20 amp current draw right at the end. It's bloody cool. That's more than twice the current what this plug's rated for. I'm really surprised that it didn't trip the circuit breakers in the house, or at least the one that it, because I had it powered by an extension lead from a different circuit, so I didn't want the lights in the workshop to go out. Cunning, you see. I've been planning this video for the last week, just thinking about it. I like to make things interesting, and when there's a bit of destruction thrown in as well, you can't go wrong. Jeez, don't do that, mistake. Right. Almost there. Another dead fly. I'm amazed there's still so many flies around. We actually had our first freezy night last week where there was ice around the garden. which was pretty impressive, to be honest. Right, almost there. One more, just down here, look. Sorry, Torchy, we need to get the drill back in shot. It's doing stuff with my left hand. It's weird. Okay, are you ready? Let's get Torchy back on the scene so you can see what's going on. Flat screwdriver. Oh, hang on, we had to take that cover off the top, didn't we? That's right, I remember now. We'll get rid of that. This is all done in the interest of education as well. It's fun and educational. And of course there's a safety element to it as well, which is pretty cool. Come on, you can do it. We all want to see what's inside. Oh, there we go. We're starting to get some movement now. It seems like... There we are. I was pulling it off the wrong side. Wow. Okay, well, the inside of that casing looks exactly the same as before, just hotter. We won't need to bother with that anymore. Wow. I can actually feel the heat coming off the motor. So, let's just unplug that one without burning my fingers. I can't unplug that one yet, so we'll just snip that just to get rid of the switch. What can we see? Well, if you remember before, there was some slight discoloration of the windings. Well, now they are literally black and burnt. Black around here and here. Both sides. Just get you a bit more of a close-up. There you go, look. That's better, isn't it? So you can see here, look, extremely black. Black, and it's burnt all the insulation off the actual wire itself. So no longer is it a winding, it's just a block of copper, so to speak. The current flow won't be going around and around, creating the magnetic field. Instead, it's essentially like one winding. And that would have massively increased the current draw because resistance would have gone right down. Look at that. That's pretty impressive. Well done. Okay, let's pop that out of there. If we can get him out without burning my fingers too much, because it's still, oh shit, it's bloody hot. Holy moly. In the interests of you, the viewers. Come on, you can do it. You can do it. I think it's melted in there. Let me get a bigger screwdriver. I really have to be quite careful where I'm putting my hands because it's pretty hot. This came out of here much easier last time. Oh, jeez, that is hot. Wow. We might have to abort mission, let it cool down a bit more. Come on, Bosch. I think it's stuck to the casing. Just pull you back. I need space. There you go, look. I think it's actually glued itself to the casing. Because if I can get that under there, you can see the whole thing is flexing and not allowing that to come out. Now, there was a lot of smoke for quite a lot of time. Let's see if we can give it a bit of a pry. Bloody hell. Don't want to break the brushes, the brush holder, at this point in time at least. Oh, there we go. We've got some movement. God. Let's try around this side. Right, we've got something now. Holy shit. Look at that. It actually stuck to the casing. and melted the casing. That's impressive. There, look. The casing entered the motor. Well, that's going to definitely help with some of the smoke, isn't it? That's fantastic. It wasn't all discoloured like this before. And again, you can see more of these windings are completely buggered. Wow. And we had some kind of contact there as well, look. What was that touching? I think that was just against the winding here. Wow. Okay, we can probably get rid of that switch. Jeez, it is hot. Oh no, the switch has melted to it. Look at that. The red switch for forwards and reverse has melted to one of the brushes. One of the brush housings. That's fantastic. See if I can prise that off. Try and hold it down, because I'm not kidding, this thing is really hot at the moment. Right, yes, okay, part of it's still stuck in the brush. That'll make life a bit interesting later on. So, next job, I think, is to get rid of the gearbox. Obviously, nothing wrong with that, although it is scrap because we have no use for it. Let's get rid of this fan if we can get it off. Oh, come back! Right. Jeez, the fan is off. God, I need some mole grips or something. Hang on, because it's too hot to hold. There we are. Nice, cool metal mole grips. Cool my hands down because they're burning at the moment. Right, I'll just pop that on there for now. Remember, this is complete scrap now, so it doesn't matter. We can get rid of that wire. Don't need that anymore. Right, so that's gone. Now we can twizzle this around. Ho ho ho, look at that! There's nothing left of the brushes. Look at that. Can you see that on the camera? There you are, look. So that brush is completely obliterated. We've just got bits. Where's the camera? There we are, look. We've just got bits of brush. Holy shit. And the brush holder itself has also melted. Massive heat build-up in this poor little motor. And you can even see, if you look carefully, the alignment of the brushes has changed. Because it's all melted, the whole thing's distorted. If I put a straight edge on there, I don't know if you can see that or not, but this one here is kinked over at a slight angle as well, like it's being dragged around with the armature. Very strange. Maybe you'll see it better on this side, I don't know, but you can see all the bubbling up of the plastic. Bit hard to see on camera, but believe me, the whole thing is slightly distorted. It's not good. Well, it is actually, it's bloody good. Right. Okay, next job is I need to remove that end cap. Now that's something that we didn't do previously. I was going to do it and then I backed off because I didn't really want to risk making the whole thing unfunctionable before we'd done our little test in the lathe. Whereas now, obviously, I can do anything I want with it because it's just scrap. Okay, let's give this a go. Oh, there we are, look. That was actually a lot easier than I thought. I was under the impression it might have been, these might have been soldered on, but in actual fact they're not. They actually clip onto these little terminals here, which is pretty cool. Well done, Bosch. Right, so we should be able to get rid of the mole grips. Ow. And hopefully pull the armature through without burning, oh geez, without burning myself too much. Oh, hell, that's really hot. It seems to be getting hotter, not cooler. God, right, okay, bit of camera work for you again. Where's Torchy? Let's get Torchy in a bit better. Look at the state. There, look at the state of that. All melted in here. In actual fact, that, oh, it hasn't bonded to it, but it's, see on this side here, this side hasn't gone quite so bad. It's still got the shape as that insulator there, look. The plastic. Whereas on this side here, it's completely blown out. There's obviously been some kind of, I reckon that's where the explosion was, in there. Wow, that is, hopefully we can get some focus on that for you. Look at that. It's pretty cool. So because of that, it's going to make it hard to get the armature out. Okay, I'll work something out. Bear with me. Probably going to involve a hammer. Or we could just use inertia. There we are, look. Ready? A bit more. Right, now we're going to swap ends. Or something like that. See if we can get that on the end of there, look. Just to hold it. Jeez! Ow, ow, ow. Okay, one armature. One very sad looking armature. What are the armature windings like? Well, oh, camera's all over the place at the moment. Obviously they're knackered, but they're not as badly burnt as the field windings. The field windings really took the brunt of all the heat. Jeez, that is just too hot. There's my pliers. There we are, look. Look at the state of that. We've got molten plastic down here. Burnt windings. It's even started to melt the outer side of the case. Look at that in there, look. That's impressive. It's bloody good. I like that. I like that a lot. Sorry, motor. But on the armature itself, yeah, we've got some burning of the actual insulation again. It's like the varnish insulator that's on the wires. Not sure there's a technical term for that, but that's what I call it. And of course, the commutator is even more blackened than it was before. Wow, that was cool. Well, it's all going to have to go in the bin now. Okay, one more factor, which is quite a good sort of learning activity on this, is to take a look at, again, this last bit here, where the current flow actually steps up. You can see for quite some period of time, come on, that's it, you know, it maintains the same level of current flow, you know, as the lathe is turning at a set speed. It's reached that optimum speed that the drill can achieve, and it's using about 8.2 amps of current draw on that 240 volt AC supply. And then at this point here, it just steps up instantaneously, and then we see further steps in the current draw by the drill. And I want to just really talk about that in a little bit more detail, because I think it's quite important to understand what's really going on inside that motor. So we'll just zoom in a little bit more on that. There we go, look. And you can see quite clearly there's a specific step, and then on that particular point the current goes from 7.9 amps up to 8.6, and then it steps up again just here, so we can measure that one somewhere around about there. I would say as an average 9.5 amps, and then again it goes up another step, and much quicker this time. These steps are getting quicker and quicker as the heat inside the motor is building up, and the insulation on the stator, the field windings, is starting to break down. And I'll explain to you very shortly how that affects the resistance of the wire. So we're up to 10 amps there, look, on that one, and then the next step takes us up to about 11.1. Got another little mini step there, look, 11.7, another step, 12.5. Just bring that down a little bit. And then realistically the motor's now in very quick demise, a few more steps, and then it gets to the final step, which is essentially just under 20 amps, which is massive. You know, it's way beyond the plug capacity, beyond the wire capacity as well, and something inside the motor just blows. One of the wires just, you know, goes up in circuit, and the whole thing grinds to a halt. Right, let's do a little doodle and see what's going on. So we know that as the motor's running, you know, we saw it on the video of the test on the lathe. The motor was getting hotter and hotter. Now, obviously, some of that heat's created by the work that it's doing, but I think there's additional factors at play here. And if we look at that, the field winding, just talk about that to start off with, because the armature wasn't that badly affected, to be honest. So the field winding, obviously, there's lots and lots of turns in that winding. And just to sort of do a very quick diagram of it and to summarize, let's say that this is the coil of wire. Okay, now I know it's very much abbreviated. There are many, many more turns of wire. But can you imagine, you know, we've got this current flowing through this particular winding, going round and round all the various loops. And in this particular one, we've got 4 loops. Now, as that heats up, the insulation, the sort of almost like a varnish really, the insulation on that wire will start to break down. And where it passes past another wire, or another part of that particular wire, at some point that insulation on the 2 parts of the wire can fail. And what that does, in a sense, is it fuses together. We've got this breach of insulation in that zone there. So now the current in that wire is no longer going around this loop anymore. It's bypassing that loop and then carrying on around the remainder of the circuit. So in a sense, the length of that wire has now reduced, and it's reduced by whatever the length of that particular loop is. And by doing so, it's reduced the resistance. Remember, the resistance of the wire, we measure in ohms, and the resistance has dropped. Well, we know, due to Ohm's law, that if resistance drops, current flow, the amps increase. So as resistance goes down, the current increases. So now there's more current flowing through that particular winding, and we can see that very, very clearly here on the screen, an instant step. So I believe at that moment in time, some of the insulation on 1 or 2 or 3 points around that winding failed, and the current flow retrospectively stepped up a notch. And then, of course, because there's more current, we've now got more heat build up. There's more current flowing, there's more heat being created in that wire, the wire's getting hotter, and of course there's going to be more likelihood of further insulation breaches. So, we can break another one. So now we've lost another loop, another winding, so to speak, another loop in that circuit. The resistance has dropped further, and the current has gone up. It's increased again, and we've got another step to demonstrate that. And this cycle will continue to happen, until eventually the majority of these overlapping parts of the winding, at certain points around that winding, we're getting these breaches. This is only a schematic, by the way, a demonstration. As more and more of those are breached, and the current travels a shorter distance in total through the wire, the length of the wire essentially becomes shorter, and the resistance drops, the amperage will get to a certain point where no longer can this wire carry such a high current load, and the wire itself at some point can just pop, and be breached like a fuse. It'll just melt basically, and it'll go open circuit. And of course, when that happens, the motor will stop. And that's exactly what we saw, I believe, on that motor, on that drill, on the lathe. So there you have it, an additional part of this video, something that I hadn't really anticipated to go into any great detail, but I think that particular waveform capture or current capture we did on the picoscope, I think demonstrates that the failure of that field winding and the stepped incremental increase in current flow, which ultimately ends up in the demise of that particular motor. It's very interesting and incredible what you can pick up with the scope.
Oh man, it still stinks in my workshop, and my fingers are actually quite burnt from doing that. What a plonker. I should have waited a bit longer, but I was so eager to get in there and see just how much damage had occurred. Anyway, hopefully you enjoyed this video. I know I thoroughly enjoyed doing it, and it's definitely been well worth the effort making the little bracket to bolt to the lathe to mount the drill. And I think my little experiment worked extremely well in providing a load. And I'm also really chuffed, it was a last minute thing, was to basically plumb up the Pico and monitor the current draw of that motor as it dies. And we could see that it almost doubled. Well, it did double. It went to about 20 amps at the end. And after the initial startup, we're at I think it was 8.7 amps. So it more than doubled at the end. And 20 amps at 240 volts, that's quite a bit of current, believe me. So hence, no doubt, that's why we got so much heat build-up in the whole thing, you know, because of all the energy going into the motor. And in all honesty, the output, the output energy didn't really change. The lathe kept going the same speed. I didn't apply any more resistance to the lathe. I didn't change the gear on the lathe or anything like that whilst the experiment was going on. Experiment, that sounds a bit technical, doesn't it? So the additional current flow going into the motor must really have just ended up as being heat, and it just turned itself into a little fireball, really. Anyway, thanks again to Pico for lending me their scope. This is a very, very useful 4-channel scope. I'll be doing lots more on that, but I keep finding different applications to use the scope. It's specifically designed as an automotive scope, but man, you know, you can do all sorts of stuff with it. It's great, good for testing and seeing what's really going on. Now, if you enjoyed the video, why not click on the subscribe button? You'll see a little gear icon turn up. Click on that, and then you can turn on notifications. And our friends at YouTube will send you an email. They'll annoy the crap out of you. They'll send you an email as and when I upload any new videos. And at the moment, I'm sort of kicking out 2 or 3 a week with a live stream thrown in for good measure. I'm going to be going back to work soon. It's going to slow down again. I am sorry. But I thought this would be quite a cool video to keep towards the end of this lockdown stint. And I think it proved to be pretty cool, didn't it? It worked out pretty well. Lots of fire, well, lots of smoke anyway, bit of a flash, and bit of excitement going on. And I hope you enjoyed my my lathe tool design test facility thing for power drills. I just woke up one night, middle of the night it was, woke up and went, I know how to give that drill a load. It worked very well in my opinion. Now, don't forget, there's also the media stuff, the socials. You can go onto Facebook, Instagram or Twitter, communicate through any of those portals. There's also my personal email address down the bottom, andymechanic@live.co.uk. Feel free to email me whenever you like. I'll do my best to get back to you. I can't always guarantee I can. Sometimes I'm just too busy. I do work long hours, but with all the filming, editing, travel that I do, and of course my day job as well, makes me an extremely busy chap. Not to mention the repairs and stuff that I do in the workshop. What else? There's a Patreon page, check it out. That's got the history of the channel, how it came to be. There's even a couple of photos on there of what this workshop, this garage, looked like before, you know, I got to it and converted it into a workshop. And I'm still sort of on with that. There's a few little mini projects still going on in the background. I'm sure if you watch a few future videos, then you'll see more changes going on. I think the most recent change visually is that shelving unit up there, look, that you can see. What else on Patreon? Well, there's profiles of all the Andy Mechanic tool girls. You can read all about their history, how they came to come onto the channel, and if they're no longer on the channel, where they are now and what they're doing, because there's been quite a few tool girls through, and every single one has their own wonderful character and has been fantastic to work with. Really has. You know, I thoroughly enjoyed working with each of the tool girls in their own way, and I think we've made some pretty cool videos. And long may it continue, is what I say. What else? Oh, you can donate through Patreon if you like. If you want to become a patron, you can get access to behind-the-scenes footage and photos. I'm going to add some more of that soon. I haven't done any recently, but there's quite a lot of photos already on there that you can download. And if you don't want to donate through Patreon or become a patron, then you can do a one-off donation if you like through the PayPal system. And again, my email is andymechanic@live.co.uk. And there's an icon that will take you straight through to a donation page on PayPal, which the icon is on the home page of the Andy Mechanic YouTube channel. Pretty much where you are now. Just go back. Okay, crew. I've got to get myself another coffee. My throat is burning. My hands need to be washed and cooled down because they're still too hot. And, well, I will see you in the next video. Thanks for watching. Cheers. Over and out.
And we get the flip up again.
Oh!